All of you might be exhausted with the lots of sessions today. I work for Eaton India Engineering Center located in Pune. Eaton is a global diversified company. It's founded in 1911, so it's a 101-year-old company with world headquarters in Cleveland, Ohio. The global sales of Eaton were 16 billion in 2011, and it works on many technologies like automotive, then electrical, hydraulics, and lot many other areas. But most of it is in the power segment and improving the power efficiency of the areas where it works on. The session which I am covering today is on hybrid vehicles. Eaton manufactures hybrid transmissions, but here I will be covering more on general aspects like how hybrid works, how they save energy, how they help us save fuel, how they help us cut emissions, and the trends which we have in global market. If we look at the definition of hybrid vehicle, it's basically a vehicle which contains more than one type of source to drive it. So along with engine, it has an electric motor, and that motor can work as either generator or a motor. So when it's working as a generator, it backs the energy into an electric source like a battery, and when it's working as a motor, it drives the vehicle. Here I have given you a typical hybrid operation, like what all modes a hybrid vehicle can operate in. These are very basic modes, just to highlight, like I'm not sure if all of you might be able to view the text, but I'll just walk through. The first phase is the ignition phase when you start your vehicle. So in the hybrid vehicles, it may not be needed that you start the engine right at the ignition phase. You can launch your vehicle in the motor mode, that's EV mode. So you save energy in your launch. Later on, we'll see in the graphs like the maximum fuel efficiency of the engine. It's in the mid-range, but if you look at the startup range, the engine is very less efficient. So we waste a lot of fuel in launching the vehicle because the engine is operating in non-efficient range. So in the hybrid vehicles, the launch is taken care by the motor when it has enough charge. When you are moving ahead, when hybrid vehicle sees that your batteries are getting drained, then it starts the engine and it uses engine and motor to drive the vehicle. When you are climbing the hill and you need motor as an assist, then it can work along with the engine to give extra power to the vehicle. So in hybrid vehicles, many companies do adopt strategy of reducing the engine size. That in turn again results in increased efficiency. So for the same type of vehicle, you can use a lower size engine, and hence you can cut down the cost, plus the emissions, plus the fuel consumption of that vehicle. When you are going down the hill or when you are braking, that's when you are wasting energy, what you had gained by accelerating your vehicle. So in the hybrid vehicles, that energy is used as a regenerative braking and it's stored in the batteries. And that's used by motor when you need it. And the most evident scenario in most of our cities in India, like whenever you are at traffic lights or any stop signals, you just stop, your engine is running at idle. That's where we waste most of the fuel. So in hybrid vehicles, it's smart enough that it switches off your engine or shut down your engine when you are stopped, and it restarts when you need it. And you have the hybrid motor to start the engine, so you need not even crank by a key or something like that. It automatically does that. And if you have enough charge on your batteries, it launches just in EV. So we get lots of savings in that mode. Here are the different types of hybridization, or I would say degrees of hybridization. I'm sure most of you might not be able to see it because of the font, but I will just walk you through what each one is. Depending on the battery which is used for the hybrid, if it's a low-end battery like a 14-volt battery, then it's called as a micro hybrid. And the applications can be just a start-stop. Now if you move to a little higher battery voltage, like if it's a 42 volt or something, then you can have something like quick start, start-stop, crank to idle, and at some point you can also have a minimal regenerative braking. If you move to a little higher range, like a 144 volt batteries, which is used mostly in the mid-sized vehicles and cars, then you can have regenerative braking plus all the features which I talked before. And the full hybrid is where you have batteries higher than 288 volts. Now this batteries which I am talking is different from the vehicle battery. Your vehicle battery can still remain as a 12 or 24 volt, which is used for normal vehicle operations, lighting and all. This is a separate battery dedicated to the hybrid system. So that said about different degrees of hybridization, I also have a graph on the screen which says when a particular source is powering your vehicle. Like the first one, over here, it's when EV mode is used, so your motor is giving power. Your motor and engine both are giving power to the vehicle. Here, your motor is getting charge from the engine, and here, your motor is getting charge from the vehicle regenerative braking. Now here we'll see like how hybrids save. So basically at the first the graphs what we see over here, they are actually the engine fuel consumption graphs with respect to torque and speed. The x-axis is the speed and the y-axis is the equivalent of the fuel consumption or something. The circles marked with red, you can see that's the fuel consumption at the launch of the vehicle, and that's very high. So that's where hybrid cuts. That's the one area where hybrid vehicles save. The next diagram which I have is over here, where I have mentioned all the different losses which you have in typical vehicle. The top one is the losses when you have urban driving, and the bottom one is for the highway driving. Now hybrids are more suited for the urban driving because we have lots of start stops and all that type of driving behavior, whereas in the highway driving that's less. If we consider losses, like 100% of the fuel, out of the 62% are engine losses. That's the maximum loss in the engine. The next loss comes in the standby, when your vehicle is standby. So almost 17% is what you lose in the standby mode. Of course, in many of the Indian cities, it's even higher because we start stop a lot. This is based on one of the US research and the typical driving cycle that they have in New York. But of course, in Pune or Bangalore or some other cities, we may even have higher losses in that. Out of that, so in the urban driving, only 19% of your fuel power gets transmitted to the vehicle to run it. Out of that 19%, we lose 6% as a drivetrain losses. So that's what your transmission loses. Then, so the rest left is just 13%. And out of that 13%, we lose 6% in regenerative or normal braking. So which areas does hybrids save? So hybrids can save by reducing the losses in the standby mode, the circles which I have marked with green. So in standby mode, it can reduce engine losses. Engine losses it can reduce by many things, like using motor to launch, then reducing the engine size. Many manufacturers do reduce the engine size, and hence they cut down the losses, they get same efficiency. Then it operates engine in a very economic band, like where engine is most efficient. Wherever we see at the higher range where engine is not efficient, it tries to use motor to assist. And it only gives up assisting when it doesn't have enough charge. So that's how it reduces on the engine losses. Braking, of course, since now we have a regenerative braking, so all the losses that you had in your braking is recaptured in the batteries and that used to drive the vehicle later on. So these are the ways in which hybrids save. Now, why do we need hybrids? I'll move away from the technical aspect to more on the sales and other aspects of these vehicles. Like the graph which I have shown over here is the oil production graph, which US and other countries plus India, they have got together and analyzed like how much crude oil we have and up to what year it can last. Of course, you might not be able to see the x-axis, but it's like up to 2050 we'll be reaching the peak production, after which there is a decline in the production. Now, if we see the energy demand, it is rising by a factor of 2. But at the same time, we have to also meet emission standards and other regulations, and we also have to reduce emissions by a factor of 2 or more. So really it's a challenge going ahead. If we consider the total world oil production, out of which 25% is currently used for transport sector. Out of the total CO2 emissions, 25% is from vehicles or the transport sector. And out of them, 19% comes just from the Asian countries. These are some of the regulations which the countries are coming up with. Like in China, you have the EU4 in 2010, then 2015 they have a higher efficiency vehicles targeted. By 2020 they want to cut emissions by 40%. If we consider US, they are also coming up with regulations to have higher mileage vehicles. Same in the India, like we have higher standards or higher regulation for the vehicles like BS4 in 2010 and 20 to 25% reduction in emissions by 2020. So to meet all of these challenges, we need to come up with the right strategies, right type of applications and right type of optimizations in the vehicles to reduce the emissions. Of course, engine optimization, reducing the emissions right at the engine stage is one area. And the companies are targeting to reduce the emissions just from the engine by 30 to 40% up to 2025. But rest has to come from the vehicle, the other technologies like hybrid or PHEV or something like that. If we consider the on-road vehicle population and the projection in next 15 or 20 years, then we can see like it's growing a lot. In 2010, it was like 33 million vehicles. This is just China, India, and the Asian countries which we have. Asian, by that I mean Southeast Asian nations. By 2020, it expects to be 54 million vehicles. In India, they expect it to be 9 million or so. Now we'll move on to like where can we have hybrids? What are the types of vehicles we have in India where hybrids can be more efficient considering the cost and emissions? So typically we find various type of vehicles in India like two-wheelers, motorized two-wheelers, motorized three-wheelers, then we have cars or SUVs, we have low capacity commercial vehicles and high capacity commercial vehicles. If we consider the on-road vehicle population within India, then the top one is the two-wheelers. We see that major segment is occupied by two-wheelers. Then comes the cars and SUV segment and followed by rest. So really seeing at this graph, it seems hybrid should be fitted into the two-wheelers. But if we see the next graph, it says the fuel consumption. Then the major fuel consumption goes in the high capacity vehicles. You can see it's 52%. Then the next major area is cars, which is 22%, even though the number of vehicles and the volume is less. So it really says that hybrid should be applied to some of those areas so that we can save maximum fuel, because they travel a lot of miles regularly and hence they end up using lots of fuel. So looking at the same graph again,